Hi, everyone. Welcome to another Deep Learning Meetup. Today, we're glad to have not just one, but two speakers. They are Ricardo and Catarina from Unbabel, and they'll be presenting their work on machine translation quality evaluation. But before I present the speakers, let me just remind you of the format of our meetup. So we'll have around 40 minutes of talk, and then we'll have 15 minutes in the end for Q&A. So please post your questions and comments in the YouTube chat during the talk so that we can ask them to the speakers in the end. So about our speakers, as I said, they are Ricardo and Catarina. They are both AI researchers at Unbabel, and they have co-authored the state-of-the-art metric COMET and the MT Telescope tool for machine translation. Ricardo is also a PhD student working on machine translation evaluation at Institute Superior Technique under a collaborative program between Unbabel and INESC ID that bridges the gap between industry and academia. Before joining Unbabel, Catarina was doing her PhD on neurosciences at Instituto de Medicina Molecular, where she studied how motivation and decision-making choices are altered in the general population and in children with attention deficit and hyperactivity disorder. So welcome, Catarina and Ricardo. It's a pleasure to have you here. And yeah, take it away.
Thank you, Ines. And thank you for the invitation and everyone that is here listening to us. So as Ines said, we are going to talk about pushing the limits of machine translation quality evaluation, and starting with the agenda for today. I'm going to talk briefly in the beginning about my project, what it is, Unbabel pipeline. And then we are going to introduce COMET, MT Telescope, the other open source tool that we have. And we'll finish with some ongoing work, especially regarding reference-free evaluation, COMET-QE, a faster and a lighter COMET, COMET-INU, and UncertaintyAware MT evaluation. So Maya stands for Multilingual AI Augmented Agent, and it's a 2 million euros project with the partners of Unbabel, Cardan University, INESC ID Lisboa, and Instituto de Telecomunicações. And the goal of the project is to augment agents with multilingual superpowers. And we can do that using several lines of research. Besides the most obvious that you might think, that is giving the agent the feature of being a polyglot. So a user can be talking with the agent about a certain problem in Japanese, and for the user it will be a natural conversation, but actually the agent doesn't speak Japanese. We just have this layer of machine translation in between them, so the conversation looks fluid, but we have the machine translation there model. But not only that, we can also think about having models to estimate sentiment analysis, for example, flagging users that might be very frustrated or just very unhappy, and those will be given high priority. So the focus of the agent should be to turn this frustration in some happiness and making sure that users at the end of every interaction would leave satisfied and happy with the customer support service. We can also think about other metrics to measure satisfaction. For example, just seeing the dialogue conversation quality. It might correlate with the quality of the translation, or if the service that the agent is providing is of good quality, or if it's just polite. You can think about several aspects to have these scores. Or we can make the agent faster. And how? For example, if you suggest some predefined answers, or even just to get to the answer, and then the agent just needs to accept the suggestion. Or we can think about the agent writing one or two words, and then having this auto-completion model that will suggest with a certain confidence the words that will come afterwards. So this agent being faster. To achieve these lines of research, we are also putting together what we call the Maya corpus, that is composed of a genuine bilingual conversation corpus. We plan to release this soon. And besides being these bilingual conversations, we will have some annotations that are very important in the Maya project. Like I said, the emotion annotations and the quality estimations. Another key aspect when we think about a conversation between a user and an agent, where we have this translation layer, is the fact that translations need to be of high quality, because if the translation is not of high quality enough, then the user will not understand what the agent is saying, or vice versa, and then the service that the agent is providing will be of poor quality and will lead to users being more and more frustrated. And that is why at Unbabel, if now we look to the pipeline, we care a lot about having systems that are able to evaluate the quality of our translations. I'm going to now guide you through Unbabel's pipeline. So we start with an order, so a text that we want to translate. The first step is to go through our data anonymization model. This is very important because we don't want any personalized or identifiable data to be exposed throughout the pipeline. And then this source, so the text that we want to translate, will go through the machine translation model. And once we have the translation, we pick these two inputs, and then we put them into a quality estimation model that we have there. We call it QE, and the logo is actually resembles OpenQV. And this quality estimation model will give us a score. And depending on how the score is, it can go either one or two pathways. If it's high enough, so a high QE score, the order will be finished automatically. So we will only deliver MT translation. If the quality, on the other hand, is low and we are not satisfied with the quality, it will go through our translation community. So we'll have humans that will post-edit the translation to make sure that the quality is of high quality, and we are confident that this should be delivered. We also have another set of community, that is the annotations community, that will pick the finished orders, and their work is to annotate every error that are still in the finished order, the severity and where is it. And this is very important because this provides us this continuous training loop to the translation community, to the quality estimation, but most importantly, to our COMET model, our metric that will evaluate the machine translations model. So even before seeing if the translation is of good quality or not, we need to make sure that the machine translation model that we have deployed is of high quality. And this is where COMET, our metric to evaluate machine translations model, appeared. For COMET, we need another input. So not only we need the source and the machine translation, we also need a reference. So these three inputs. And the reference is a machine translation that was post-edit or it was created from scratch by a human. So it's like a gold translation. And we pick these three, and with COMET, we can see if how good it is, the MT model.
Right. So, as Catarina said, to enable multilingual conversation, we really need to care about the translation quality. Otherwise, people just don't understand each other. And the motivation behind creating, so we have this reference. We have a machine translation system. We ask the system when we are training several systems and we want to experiment with different architectures and those kind of things. We ask the system to translate a given test set, and then we take that test set and we compare it with what we call the references, so our goal truth, in order to have an estimate of how good the translations are. And then we use an evaluation metric to help us understand if a system is better than the other. So in that sense, the evaluation metric shapes the direction of our research. We use it to identify system weaknesses. We use the metrics to decide if our new system is better than our older system. The problem is that MT evaluation is very hard. We have this reference that was created by a human, but it's just one valid hypothesis because we can translate the same things in different ways. So it's very hard to just look at the translation and say if it's good or not by comparing it with another translation. And at the same time, we can rely on humans. Here we saw in this annotation step over here, we are basically periodically we ask humans to do the annotations, but this doesn't scale and it's very, very expensive. So for that, instead of just relying on humans, we, as I was saying, we can just try to compare by looking at the number of words that match between the translations and the references. That's the popular n-gram-based metrics. We can, if we don't want to just look at these lexical similarities, because sometimes they are not enough to capture if the translation is good, we can use the embedding-based metrics. But the problem, I don't know if you guys are very familiar with embeddings, but for instance, embeddings are these semantic representations that we can use to extract semantic meanings from sentences. The problem is that when we are using embedding-based metrics, if you take, for instance, I love you or I hate you, the semantics are kind of similar. So it's going to assign a very high score, and they mean totally different things. And then there is a new category, a more recent line of work, that is learnable metrics. And the goal of learnable metrics is to actually learn to evaluate translations like humans do. And we will see how we can achieve this. And our line of work, COMET, builds on these metrics. So with that said, our architecture is follows. We have two distinct models, but this is our main architecture. We have a pre-trained encoder that we use to create a representation for the source, a representation for the hypothesis, so our translation, and a representation for the reference. And don't forget that the reference is a translation that was made by a human, but this translation can be completely different than what we are trying to score, which is the hypothesis. And then we just, after taking these embeddings, we just play with them in terms of trying to combine them together in order to create features for a feed-forward that will produce a score. And the way we play with those embeddings is that we apply the element-wise dot product and the element-wise absolute difference between the embedding of the translation and the source, and the translation and the reference. And here the idea is that I want to know how close in the semantic space is my translation from my source and my translation from my reference. So I want to know if those three things are clustered together or if they are just very far off each other. If they are far off each other, probably my translation is bad. If they are close together, probably my translation it's of good quality. And in spirit, this is similar to the embedding-based metrics, but the difference is that this feed-forward has the capacity of learning that maybe the score of I hate you and I love you should be very low. So this extra layer of supervision that we add on this feed-forward is what actually makes the difference. On top of that, we also have the translation ranking model, where we optimize the embedding space in order for here the translation ranking model during training has to receive not just one translation, but it actually has to receive two translations, where one translation is good and another translation is bad. And we will see later how we can create these pairs of good and bad translations. And then the model also receives the anchors. And the idea is similar, but instead of having a feed-forward here that will try to learn to produce a quality assessment, we just try to create this embedding space that respects that order. So in the sense that the good translation should be closer to the source and reference, and the bad translation should be far away. And these are the two main models, the two main architectures that we have inside COMET. And now, as I was saying, COMET is a metric that will try to evaluate translation the same way humans do. So it's very important to understand how humans perform translation evaluation. And we have three types of human assessments. In this case, three types of ways that humans are used to evaluate translation. One is human mediated translation error rate, which is also called H-star. The other is multi-dimensional quality metrics, and finally the direct assessments. So starting with the H-star, recall that when we have one thing that we actually do at our pipeline at Unbabel is that when we have a translation that it's not very high quality, we ask humans to post-edit that translation. And what post-editing means is that we ask humans to fix the translation by changing the minimum amount of words that they can. So the human doesn't have the freedom to just delete the translation and completely write it from scratch. They have to try to preserve the max of the maximum of the original words from the MT engine. And when they do this, they create what it's called a post-edit, which is a perfect translation that started from a machine translation system and then was fixed by a human. And at the same time, we have another way to create the translation that we can ask just the human to translate it from scratch. So if we have these 4 segments, we can estimate the quality of the translation by just making an edit distance between the MT and the post edition. And what this edit distance will give me is the amount of words that I need to change to fix the translation. And that score can be used as a proxy of how good the translation is. So if a translation made by a machine translation engine was perfect, we don't need to change anything. So this score will be 0. If there is like 4 words that needed to be changed, this will be something close to 0.4. And now if we have this score, so we can come up with these scores by making by comparing these 2 segments. But then after having this score, we can just ignore completely the post edit, and we can train our COMET metric to, given the source, the MT, and the reference, try to estimate how many words I need to change to produce a P. So this is one way that people use to evaluate MT, is to use this post edition on top, and we can train a metric to produce this score. In terms of corpora, there is publicly available corpora of post edition. I'm just here citing two corpora that we used for this purpose. It's the KT21 and the ApeQuest. If you concatenate them, you have a lot of data, 211K samples covering 7 different European languages. So this is a lot of data. Now, one problem of H-star is that if you have a punctuation error, or if you have like a named entity error, of course, the named entity is something that it's much more important than just a punctuation error. But the way that you evaluate MT by using post edition, it considers both errors equally wrong. So there are other types of evaluation that try to be more try to penalize errors differently. The most the most reliable way to perform human evaluation is to use MQM. And on MQM, people usually have to go through the translated text and they have to annotate where errors are. And those errors are then marked with different severities. So if it's just a punctuation, you just assign a minor error. But if it's something like a named entity, you can assign a major error, and it can go up to critical errors, very bad, nasty errors that might change completely the meaning of the sentence. And then after you get these annotations, you can come up with a score based on the multiplication of the number of errors by the weight of the severity of the error. You have different ways to do this, different ways to scale different types of errors. At Unbabel, we use a scale where criticals have 10 times the weight of minor errors. But for instance, Google doesn't use the concept of critical errors, although they have this non-translation error that is like a super critical and has a weight of 25. So, but the idea is very simple. It's like you ask humans to annotate where errors are, to assign a severity, and then you come up with a score for each segment based on the number of errors multiplied by the weights. The problem of MQM is that it's very expensive, and for people to do this, they have to be really experts in the language. So it's not very suitable if you have millions of sentences that you want to score. And that's the use case of the WMT News Translation Share Task. So this is a competition that every year occurs since 2008. And in that competition, they want to, several teams participate to decide what is the best machine translation system. And these teams include Google, Microsoft, like a lot of the big tech companies participate on this. And to decide the best system, they have to perform this human evaluation at scale. So they have to, for each source in the test set, they have to give scores to like 10 to 20 different translations from different systems. So they do this by using direct assessments. And you can think of a direct assessment as a rough estimate of the MQM score. On the MQM score, you have to actually know where the error is, and then you produce the score based on the number of errors. On direct assessments, you just ask a human to give a score from 0 to 100 of how good he thinks the adequacy of the translation is. So in the setting of WMT, you get something like this, where you have a source, you have a reference that was a human-made translation, and then you have several systems, and those different systems have different scores that were assigned by humans. So because of the fact that you have the several translations for the same source, and because of the fact that you have these scores, you can also come up with relative rankings, where you can say that this hypothesis is better than this one, because if you remember here the points, like this one was assigned 0 and this one was assigned 90, and they use a threshold of 25 points to come up with this better and worse hypothesis. So you can imagine how this fits well in our translation ranking model. Right. So if you after you understand the way that people usually evaluate translation, and after understanding our models, you can more or less see how we come up with these new metrics. But before I just jump into the results, remember that they use these relative rankings. So they create these relative rankings directly from the direct assessments. So the way that in the WMT shared tasks, the WMT shared tasks, I forgot to say this, the WMT shared tasks are not just competitions for translation systems. You can also compete with metrics. And the way that they evaluate how good the metric is basically they want to measure how many times a metric assigns a higher score to the better hypothesis and a lower score to the worse hypothesis. And if a certain metric always achieves this ranking correctly, then that metric is producing a perfect ranking. And if a metric does not produce a perfect ranking, it's like it only if the metric only half of the time gets it right, then the score is going to be 0. So they use this Kendall-Tau-like formulation where -1 is a negative correlation, so it's the opposite of what you are intended to do. 0, it's like it's random choice, and 1, it's like a perfect metric. And the first time we participated in this competition, which was in 2020, both our COMET estimator, so the model that was learning to produce direct assessments, and our COMET rank model, which doesn't learn to produce a ranking, but doesn't learn to produce an estimate, but learns to rank different hypotheses, they were both achieving very high results compared to previous metrics. And these 3 metrics were proposed that same year. And these 2 metrics are the most used metrics nowadays. Even after our metric was proposed, the academic, like the research groups, still heavily rely on these metrics. And these are lexical metrics. So basically, they only look at how many words overlap between the translation and the references. And for into English, we already had like 2% difference from other metrics that were proposed the same year. If we consider out of English, which is a more challenging test set, we see even higher results. And what is interesting is that if you take COMET, it doesn't really matter the type of ground truth that you are trying to learn, because if you try to predict on MQM, H-TER, or direct assessments, you still get very high results, and the difference is not that big between one or the other. And also, if you test it with languages that do not involve English, they still perform well, although they never seen this during training. So they are only trained with data that either has English on the source or in the target. But since they are trained for several different languages, in the end, they actually learn to generalize to unseen language pairs like German into Czech. And basically, these were the papers that we wrote the COMET paper on 2020. On that same year, we ended up participating on the competition for the metrics. We ended up winning at several language pairs. We didn't it was very hard to decide the final winner, because between us and a team from Google, we got statistically tied in several settings, but we won most of the language pairs for the segment level, which was the setting that I explained, where you have to rank different segments. And I'm here this is our participation paper, and this is the results. If you are interested in this, I advise you to read them. And now, so this is basically our participation to 2020 share task. We kept working on this, and what I'm going to explain more towards the end is what are the new improvements that we have been doing for this metric.
Okay, now I can talk a little bit about MTs Telescope. So MTs Telescope came from a real pain that we have at Unbabel. That is, when we developed a new model and we want to compare to the one that is already in production, we might end up with COMET scores that are very similar. So for example, in this case, it could be 86.7 and 86.8. And then the question that our developers have is, should I deploy the one that is on the right just because it's a little bit higher than the other one? The problem is that normally these scores are average scores across several segments that compose the test set, but they don't tell us the full story. Actually, the one that has a little bit higher score can be failing things that are very critical to our business, and so we shouldn't deploy that one. We should continue with the other one. So MT Telescope is a tool where we can have several graphics, several features, and here we are highlighting two. For example, we can build this type of bar bucket plots where we group the buckets according, for example, with 4 different ranges. And the ranges actually can be adjusted according to what the user wants. And what they are very useful, because imagine that these two systems, system X and system Y, actually have very, very close scores, but what we want is to avoid critical, so segments that will fall into these red buckets. So in this case, actually, even though system X might have a higher score because it also has more segments in these red buckets, actually that model should not be the one deployed in production. The other useful plot that we have is the bubble plot that we see here. So a kind of scatter plot where the bubbles are bigger and darker when the difference between systems are higher. And with that, we can look to segments that have this higher difference and to see where one model is failing over the other one. For example, in this example, we can see that X score is much lower than the Y score, and we don't need to look into attention, but basically what was happening here is that the X system was failing producing the name entity, and that will mean a critical error, and it was good that the COMET was able to understand that and give a such lower score to that system. So MT-Telescope has these 3 main features that are summarized here. So it has all the state-of-the-art evaluation metrics like COMET, PRISM, BERT score, but also the other traditional lexical metrics, like Ricardo saying, that basically look to the lexical context, like BLE, CHRF, and TER. We actually advise that when people are looking carefully into comparing 2 systems, they don't use just COMET, for example. We advise that people should use as much metrics as possible, because only then we can make a more informed decision. We also implemented statistical analysis because when we are comparing 2 systems, we want to see if the difference is significant or not. And we also have another feature that we call dynamic corpus filtering. And we implemented so far entities, terminology, and length. And for example, if we have a test system, but we just are careful, we just look for name entities, how these 2 systems behave on name entities, we can filter that first. So we end up with a corpus that is smaller, but only contains segments with name entities, and then we perform the analysis. So we'll have COMET scores, but only in that custom test set that we care about.
So before we jump into ongoing work, I'm just going to back really fast to the pipeline, and maybe now the pipeline is slightly clear. So we don't want to put into production a system that produces low quality. So when we are developing this system, we need to use metrics that are reliable, and COMET is the most reliable metric so far, because of the things that I said. It tries to mimic the way humans evaluate machine translation, and it's like a neural network that it's much more complex than simple word overlapping metrics that are commonly used. And on top of that, we also have this analysis tool that it's Telescope, where we can look deeper into the different types of translations, and we can try to spot where the system is failing or not. So if we use these 2 tools, we can almost be 100% sure that the model that we are deploying, it's very high quality. Now, after we deploy the model, doesn't mean that the model doesn't have some errors sometimes, and this needs to be clear to understand the next part of the translation of the talk. Sorry. So going back to where I was. So one curious thing that we discovered when we were writing the first paper and doing these first experiments is that On online settings, when we actually put the model into production, we don't have access to a reference. So we don't have access to this ground truth. We just receive a text, we ask the MT system to translate the text, and then we don't have anything to compare that translation. But we can still try to come up with these models, these neural models that try to predict the quality of the MT without using the reference. And because of that, we just decided to do some attempts, and we ended up competing with that model the first time. We didn't have a lot of results for that model at the time, but the authors of the share task highlighted the model as being one of the best models in terms of reference-free evaluation, and it was very competitive with models that actually use the reference. So our model that doesn't receive any expected output was performing as well as models that receive an expected output. And not only them, another team, independent team from Microsoft, they did this large-scale study on the machine translation metrics, and they discovered that the COMET that uses only the source, so the same model that I was explaining, but without any reference, was competitive with our model that uses the reference and was above all other metrics. And these metrics over here, especially Prism and BERT, are very high state-of-the-art metrics. BERT is our competitor from Google. So we started asking the questions if we really need references. Maybe we can just use a model that is completely reference-free. And this would be nice because we could have the same model to evaluate the systems and to decide which systems go to production or not. And we can use the same model maybe after the model is into production. We can just use it to decide if a translation goes directly to the client or if it needs some work to do. The architecture is very similar, but stripping out the reference. And because of this very surprising result, we decided to focus our submission for 2021. So we ended up competing again, but our main focus was, one, to do the model reference-free, and second, to try to come up with something that was faster and lightweight. Because all our models rely on XLM Roberta. They are actually dual encoders or triplet encoders that use XLM Roberta. So these models are very heavy compared to older approaches that are lexical based. So those were our two focus on the last competition that we participated. And another focus that we had is we used MQM data before, but the MQM data that we used before, so we trained from scratch on MQM. And the MQM data, because it's more expensive to come by, we don't have that many data points. So one thing that we tried this year was to first take the direct assessments data from the WMT, which is very large scale. You have a lot of segments. Train the model to produce or to be able to evaluate translation based on direct assessments, and then transfer that knowledge to MQM by using fine-tuning on MQM data. Now, the only problem here is that MQM and direct assessments are not in the same scale, so we had to normalize the data in order for it to be on the same scale. But after doing this, we can take our models that were based on direct assessments and then do fine-tuning to come up with models that are based on MQM. And this worked much better than just training directly on MQM because of the fact that we don't have that many data points. Now, another thing that, since we were focused on this approach where we didn't have any reference, we decided to experiment with another tool that was developed by Unbabel called OpenQV. OpenQV was made for producing okay and bad tags based on post edits. So it's slightly different than what we were trying to do here. But we decided to give it a try and use it to produce MQM based tags instead of post edition tags. And another interesting thing about this model is that it's trained on multitask setting, where you have to say which words are correct and which words are not based on MQM annotations. But at the same time, you have to use the CLS token, or the first token of your input, to produce an MQM score. And if we just look at our preliminary results, we see that, first of all, doing this fine-tuning on DA and then transferring for MQM really boosts our results. Another thing is that Cometinu, which is our lightweight version of Comet, is already performing almost as good or better than our model from the previous year, which is this line over here. And a very surprising result is that our models that don't use any reference are very competitive with our models that use references. And this is a very positive result. Even our OpenQV model, which is a completely different model, is at least it's better than other metrics that use reference, and it's almost as good as our model from last year. And in the end, so these results are from November. In the end, we ended up again tied with our colleagues from Google. We ended up winning 10 settings, and Google the same. They also improved their metric. This new metric that is CSpec, it's a new metric that it's actually based on both BERT and COMET. So I consider this a win for us. But a very surprising result is that our reference-free evaluation methods are above all of these metrics that are reference-based. So we can create ways to evaluate machine translation that don't require the existence of this expected output. And this is a very positive result, because creating this expected output, sometimes it's not easy and it's not cheap. And also because we can use the same model to evaluate systems, and also to decide if after putting the system into production, if we want to deliver a translation or not. Right. So this is in terms of the metrics themselves. Another work that sparked after our Comet work was one thing that we noticed is that all metrics produce just a point estimate, and this is old Comet. Old Comet would receive this source, this reference, and a given translation, and would produce this score over here. And sometimes because this is an error network, we note that the score is very far from the ground truth. So it would be also very interesting if our metric would produce some level of uncertainty that would tell us if the model is sure about the prediction or not. And that's our work on UncertaintyAware MT evaluation, where using these different uncertainty methods, instead of just producing a point estimate, we actually produce a distribution of scores, where the mean score would be the score that we actually use, but we also have this confidence interval that we can look at to see if the model is more certain about the machine translation quality or not. The way we achieve this is based on two very simple techniques: deep ensembles, which is basically we train several systems with different seeds, and then we just average the results, and we have So instead of running one model, we run like 5 models to get 5 different predictions. Or with Monte Carlo dropout, where we just activate the dropout layers during inference, and instead of asking the model to produce one score, we run inference several times to produce several scores. And just with these simple techniques, we are able to, for instance, prove the impact of reference quality. For instance, if the reference is not very high quality, so if my expected output actually contains some error, my model is going to be more uncertain. And this is good because it can also be used to, for instance, identify bad references if we care about them, because we can also try to use these methods without the references. But this work, it's a very nice step in towards trying to understand how these big pre-trained models are working in the setting of MT evaluation. And also a very nice thing is that if we do this, and instead of having one score, we actually have several, and then we average, this actually improves our correlations. And here we can see more or less why. Because even though COMET was very far from the ground truth, the confidence interval is very wide. So if we actually average the results, we get something that is more close to the ground truth than it was actually. And yeah, basically, this is everything about our work and our work, our older work and our most recent work. So now, if anyone has questions, we can gladly answer them.
Thank you, Ricardo and Catarina, for your presentation. So we have a couple of questions from the chat. I'll start with Andres' question. And he asks, how do you evaluate the quality of the translation in the first place? So how does the KE work?
So we have several ways to evaluate the quality of the translation. That was this part over here. The way, like, when we want to evaluate the quality of translation, we ask humans to do it, and we get that from ground truth. This is if we want to go for a human evaluation, but automatic evaluation is when we try to mimic these results, right? Does that make sense?
I think that he's talking about QE, like in the pipeline, the OpenQV. So it's basically like what we talk about COMET, but without reference. That's why in the online loop, when we don't have the reference or the goal translation, we use QE, so the green icon, and not the COMET that does require, at least the normal COMET requires to have the 3 inputs. Yeah. From what I understood, that was the question. But Andre, right, please correct me if I understood it wrong.
Yeah, I think that's it. Otherwise, Andre can also comment on that. And we have, let's go to the next question. So we have another question from João. João asks, since sequence-to-sequence models can generate several candidates, do you use metrics like COMET to pick the best translation?
We have an ongoing work where we try to do that. So we try to put the work on COMET and this work on evaluation closer directly to the MT engine. So we generate several hypotheses with beam search or something like that, or just nucleus sampling. And then we try to use these methods to rank the different candidates. It works well. So, but by the way, it's very hard to beat decoding algorithms like beam search. So in our experience, it improves a little bit if you rank, but not much.
All right, thank you. And another related question I have is that a source sentence can have many correct translations. Can we optimize COMET with respect to secondary metrics, for example, maximum score when it is correct and empathetic?
I don't. Can you
I mean,
repeat?
yeah, can we take into account like other aspects? For example, if the translation is empathetic, other aspects other than being just correct, because we can have a lot of correct translations, right?
Right. Yeah, but like so this always depends a little bit on the type of assessment that you are trying to produce. For instance, if you train Comet to produce MQM scores, that should be taken into account, because the MQM scores, you actually, when you create these annotation spans, you take into account a lot of things like grammatical register and those kind of things.
Yeah, if you want, for example, an informal and the sentence is completely correctly but formal,
Yeah.
MQM will have that into consideration and probably will put even a major, because it's not a minor error when you want another formality. So common in that sense, yeah, it's a learnable metric that is robust to that kind of thing. So it depends on what you are annotating.
Yeah. Actually, in our pipeline, we have when we have in this step over here where we have QE. In this pipeline, we have a QE model that is very similar to Comet, trained for formal tone and informal tone, just to try to take into consideration those nuances of the translation.
So you have two models, is that it?
Yeah,
Yes.
depend on the brand and the customer, because in customer support is really important for the brands to actually they speak in the register that you want. If you're talking about I don't know, for young people might be informal, but if you want more a formal brand, will never have the translation in an informal tone.
Yes.
So it's
makes
super
sense.
critical in terms of business.
Thank you. All right, so we have another question. Here, the question is, in production, how do you trust your COMET score? Imagine the scenario where you get out of distribution data that your COMET model never saw during training.
So Comet, the Comet is usually not used online, so it's used more offline during the part of continuous training. Sometimes that happens in terms of, but since it's made offline and you always have a reference, what happens is that it can be a different sample, but you have kind of an expected output that you can rely on. So in those cases, I think Comet is very safe because it's just trying to compare semantically and in terms of syntax if it's close to the reference or not, and you always have that expected output there to help you. I think that's more problematic with quality estimation, where you don't have that expected output, and that sometimes happens. It's some risk that you take. Although some works like the work that I presented last in Uncertainty, they should try to capture that. So this is something, if I'm giving you something that is completely out of distribution and that you have never seen during training, the confidence intervals should be very wide. So your prediction of quality shouldn't be very, or in theory should not be very meaningful because of your confidence intervals are so large.
And the other thing that we might add is when we think that we shouldn't trust Comet because of some reason, we also have the other metrics to help. So we might turn to lexical metrics that we understand better, because basically they can rely on matching, and then we see if they are in concordance with Comet or not. That also helps.
Yeah, we always have these redundancies, right? Even Telescope, the fact that when we are trying to decide if we deploy a new system or not, the fact that we need to look at Telescope to see several metrics, to see statistical significance, to see all of those things. So in the end, you have a clear picture.
Yes.
But that's a valid point. You still have some samples that are out of domain, and sometimes your models can fail, and that's fine. You have some works that already try to improve on that, like this one.
Yeah, and talking a bit about out of distribution, do you also use the COMET metric for active learning, for example, offline, to decide which samples should you give to an annotator to translate correctly, because the quality of your model is not that good yet?
Yeah, we are starting something similar, but so far the way that we decide to annotate things, it's still random. It's
Okay.
not truly
It's
random.
not truly random, but we don't have a lot of filters. We
Yeah,
are working
we don't
on
have
being
Comet
clever to yeah.
And do you think COMET can be used there?
Yes, there is some experiments that they are doing that show that we can actually be more creative in the way that we select things for annotation. And one of them is to actually use Comet and OpenQV to help.
Yes, makes sense. All right, so we have a question here from Luis. Luis asks, do you think we can use a similar strategy to evaluate hypotheses in other tasks, such as automatic summarization?
Yes, we actually already had that discussion a little bit. So my problem with the other tasks is the fact that you don't have a lot of annotations with these ground truth scores that were assigned by humans. And that makes it hard because our network needs to learn some kind of scoring function. And that scoring function is learned by the annotations that were given by human. Before I started working on this, I was working in dialogue, and I would love to apply this to dialogue generation, which is similar. It's a generation problem. Also, maybe you can compare it with summarization. But the problem is always that you don't have this fine-grained type of analysis that you could do, you could use. With that said, there is a new benchmark, like a new leaderboard where you can submit systems, you can submit metrics, you can submit a bunch of things. And someone submitted Comet for summarization, and it was one of the best performing metrics. I don't know what this really says because we never trained it for summarization, but I really think you can use it.
So it's very correlated with the human summarizations. Is that how they measure it?
Yeah.
Right. Yeah, interesting.
They probably, instead of using the source, they pass the part of the document, because you cannot fit more than 512 tokens. But they probably put instead of the source, they just put the document and then the hypothesis and the reference, and it seems like it correlates well.
Great, that's very promising. Yeah, also related to COMET, in the first few slides, you showed the architecture, and just to make sure that the encoders are fixed during the training, have you tried to also fine-tune the pre-trained encoders?
They are not fixed. They are they are trained. So
okay.
Basically, we have this. We do this on steps. So we start by just fine-tuning the feed forward, but then we unfreeze everything. We also have different learning rates. So the learning rate here is always higher than the learning rates over here. In the end, we end up fine-tuning everything.
Yes, yeah, makes sense. Also, another question I have is that could you use this COMET metric for the translation model itself as like the training objective?
There is work on that, not done by us, by the way. A group from Dublin, I don't know, but that's called MRT training, minimum risk training. People have done it with several metrics, not just Comet, but Comet seems to give good results. The problem with MRT for machine translation is that it's very heavy, and the results don't seem to compensate how slow it is to do the training.
All right. So you don't gain a lot and you take a lot of time to
Yes,
train.
and it's very hard to calibrate because, like, when it's image, you can, and you are, for instance, trying to build again, you have like the discriminator and you have the generator, and everything is differentiable. When it's text, since you don't have a differentiable output layer, you have to rely on reinforcement learning techniques, and that those techniques make the training very unstable. So it's very hard to find the proper hyperparameters. It's very hard to achieve good results. There is some people working on that, but so far I think we are still far from getting or collecting those benefits.
All right. But it's interesting that other people have taken your work and tried to move it to other directions. Yeah, I think we are just in time. And just to make sure, the COMET is available, right? It's an open source tool. If everyone wants to try it out, they can use it out of the shelf, right?
Also,
Yeah.
MT Telescope.
I think I have here.
You have in the last slide, you have the links for both GitHub repository. They are under Unbabel.
Great. Thank you. So I'd like to thank our speakers. Yes, it was very interesting. And also for the viewers, you have the feedback form in the link description. So please fill it out so that we can improve. And we see you in 2 weeks. Bye-bye. Thank you.
Bye.